In this video, we are going to talk about transformations in sine functions. So transformations basically means the types of changes. So we'll look at all types of transformations possible in a sine function, and we'll see with the help of amazing graphing tools available in the market. Now, before we jump onto that, we need to know the general formula of a sine function, how it looks like, and what are the variables in them and what each variable indicate the types of transformations possible. So this is the general formula of a sine function. Now you can see there are lots of variables here in this general formula. Well, this y, what is y? Well, we know that y is a function of x. Do we have x here? Do we have x here? Well, we don't have x here. We have the function here, which is theta, the angle. So when we talk about trigonometry and all the graphs, we are focused on the angle of function. The angle is represented here by the theta, which can be in degrees or can be in radians. So since this is in theta, we can replace this y by function of theta. So we can actually write this as function of theta, because our function is theta here. So now this y, where the y is, this y is always the dependent variable on the x, right? So here this function of theta is dependent on the angle, the theta. So theta will be represented on the x-axis, and function of theta, well, you can see it will be represented on the y-axis. I want to do a quick recap of why we have written it like that. So we can see, you guys must have seen writing this. Well, this is absolutely correct. Here y is equal to sine of x, means this y is dependent on the sine of x. So however the value of x will change, the y will change correspondingly in the corresponding manner, in the same manner. So now one more thing, well, you know this, why we say function of x, because we write y as function of x. So you can write y equals sine of x, or you can write function of x is equal to sine of x. It's the same thing. But here we talk about angles. An angle has a measurement unit which is called theta. So what we do actually is we write function of theta, and we write sine of theta. So here theta is represented on the x-axis, and this function of theta is on the y-axis. So because this function of theta is dependent on the value of the theta, as and when the value of theta will change, sine of theta will change, and thus the function of the theta will change, the y value will change. I hope you understand that now. Well, as you can see now, I have chosen different colors to indicate the different variables in the general formula. So here a, what a actually means, we have seen in our previous videos. This a is a factor of this whole thing here, sine b theta minus h. Now this a is actually what? This a is the amplitude. So we know that a is the amplitude of the sine function here. Amplitude means what? Amplitude means how much above the midline and how much below the midline the function will oscillate. That's the value of a. Now let's talk about the value of b, the blue. B is what? B is the period of the function. Period means one complete cycle of the sine function. So how much it travels on the x over the angles to complete one full cycle. Now we should also know how to find So amplitude is basically, we find it by doing absolute value of a, and in the same way, if we want to find period of any sine function, we do 2 pi divided by absolute value of b. That's how we find the period. That's how we find the period of a function. Now, what is h? Now, h here is a very important thing. H actually represents phase shift. Phase shift. Now, phase shift is also called horizontal shift. Means how much the sine function will shift left or right. In the same way, k here is vertical shift. Now that means how much the function will shift up or down, how much the graph will shift up or down. So these are the meaning of the variables and what they indicate in a general formula of a sine function. Now we'll take an example to understand that, and then we'll go on the graphing. So let's take an example. Let's write y equals, let's say, 2 sine. I'll need to change colors. So I'll go with changing colors so that we can actually understand what's going on. So y equals a. Let's say a is 2, and then we say sine. It's a sine function. Sine b. Let's say b is 3. And then we say sine theta minus, let's say, the value of h is pi by 2. So we'll close the bracket, plus k. Let's say k is 4. So now we should always keep in mind that this y is basically what? The function of theta. So now we'll quickly write all of them one by one. So what is the amplitude here? Well, amplitude is given by the value of a. You can compare it with the a here. A is 2. So value is given by absolute value of a, which is absolute value of 2, which is 2. Now let's move ahead. How much is b? B is, you can see, b is 3. And b is what? B is period of the function. How we calculate b? So b is calculated by 2 pi over absolute value of b. Now 2 pi over absolute value of 3 is 2 pi over 3. So period is 2 pi by 3. That's 2 pi over 3. That's the period of this function. Now let's move ahead and let's talk about phase shift. We call it in the geometrical language phase shift. You can also say it's horizontal shift. That's calculated by the value of h. Now what's the value of h? As you can see, it's in green. That's pi by 2. Now that's pi by 2. Now one more thing I would want to tell you here. We have negative here. Theta minus pi by 2. That means the shifting, horizontal shifting, will be in the positive direction. It will move, graph will shift to the right. So whenever there is negative there, that means the graph will shift right. And whenever the value of h is positive, then it will whenever the sign is here positive, that means the value of h is negative, and that means the graph will shift left. That's what we talk about. Now let's move to the vertical shift. Let's talk about the vertical shift. Vertical shift is given by the value of k. Vertical shift is given by the value of k. Now k, as you can see, is 4. So now we know that the graph will move up 4 and down, move up 4 or down 4. Now the positive value of the k, if the k is positive, if I'll say that k is positive, we shift up, and if k is negative, we shift down. Actually, in the same way, I would like to write for h as well. So let's write it there. So I'll write that if the value of h, this is h, so if h is positive, if the value of h is positive, we shift right, and if the value of h is negative, we shift to the left. That's what we do. So we'll see how we can draw this function on a graph, and it will be very, very clear to us. Now, as you can see, I have taken help of an amazing graphing tool which is called Desmos. As you can see, this is powered by Desmos, and we are going to show the transformation of sine theta over this graph, and we'll see how each one of the transformation comes alive. So we'll have a look. So let's talk about that. Let's write function of theta. Let's talk about function of theta. Function of theta is equal to, let's talk about the basic one, sine theta. Now, as you can see, we have the graph of sine theta here. Now, graph of sine theta passes through the origin. You can see 0, 0 here, and the one complete cycle starts from 0, 0, and it finishes at 2 pi. You can see it's 2 pi, 0, and so that's one complete cycle. The value of b is 2 pi. Now you can see one more thing, how much high it goes. What's the y coordinate here? It's 1, so it's going high 1. And how much down it goes? Maximum, it's -1. So the amplitude is 1. It goes maximum 1 up, and it goes maximum down to -1. Now if you'll compare it to the general formula which we talked about, well, the value of the k, if you talk about k, is vertical shift. There is no vertical shift because k is 0 here. So it's oscillating. This graph is oscillating on the x-axis. You can see this is the x-axis. This is where it's oscillating. Now let's talk about if we change its amplitude, what will happen. If we change the amplitude, what will happen? So function of theta is equal to 2 sine theta. As you remember, that was 2 sine theta. The value of a was 2. So now you can see the blue graph here, represents 2 sine theta. Well, you can see that only the amplitude has changed from its parent graph. It's 2 up and 2 down. The period is still the same, it's 2 pi of the below graph, as you can see, still the same. Now let's talk about if we change the period, what happens. If we change the period, what happens. So let's write this one. Function of theta is 2 sine 3 theta. Now what has happened? Let me erase the parent function sine theta here to make you see what has happened here. Now the blue one is the 2 sine theta. The blue one is the 2 sine theta. Now you can see the period one complete cycle is 2 pi, as you can see that. But what about the red one? The red one also has an amplitude too. The red one, if you look at the red one now, the red one also goes 2 and the blue one also goes up till 2. You can see they both go 2. But what has changed? What has changed is the one complete cycle, the period of the blue one is 2 pi, as you can see, but one complete cycle of this one is reduced to 2 pi by 3. Why? Because the period is 3, so we'll do 2 pi divided by the absolute value of b. B is 3 here, so 2 pi by 3. So you can see one complete cycle of the red graph is 2 pi by 3. That's it. That's how we do it. Now let's do some shifting. Let's do some vertical shift. Let's do some vertical shift first, then we'll talk about horizontal shift. So let's do some vertical shift. 2 sine 3 theta plus 4, and let's erase the first parent function. Now you can see what has happened. What is the value of k? The value of k gives us how much up the function will go. So now this 4, as you can see, y equals 4 will become our midline. Y equals 4 is our midline. Midline means what? This is the line across which the function will do its oscillation, like that. So it will go from 4, as the period is 2, from 4 it will go 2 units up until 6, as you can see. It's going 2 units up to 6, and it's going 2 units down to 2. So it will go 2 units up because the period, because the amplitude is 2. So 4 to 6, 2, and 4 to 2. So it's going down 2. So the sine function has shifted from here to there. It has shifted 4 units up from 0 to 4. That's what the value of k tells us. What will happen if I'll do minus 4? As you can see now, minus 4 tells me that the graph will shift downwards to the negative y-axis. Now from 0 it has gone down to minus 4. So now this y equals minus 4 is the midline of this graph. As you can see, y equals minus 4 is the midline of this graph. At y equals minus 4, it's going up to 2 units. Minus 4 plus 2 is minus 2. And it's going down to 2 units. So minus 4 minus 2 is minus 6. So it's going up 2 units and it's going down 2 units because of the amplitude. Amplitude is 2. So this is how it works out. But in our question it was plus 4, so we'll do plus 4 and would like to show you and keep you there. Now let's talk about the horizontal shift. Now that's very important. So what we'll do is function of theta 2 sine now 3. Now the horizontal shift is going to be there in theta, so keep it in bracket, theta minus, If you remember, it was pi by 2. Pi by 2. And we'll close the bracket and then plus 4. And let's erase the pan function there, which is this one. Now what has happened? Now what has happened? Now what has happened? Please have a closer look what has happened. The function, the blue function is our original function 2 sine 3 theta plus 4, where there is no horizontal shifting, means no left, no right. That's our original one, the blue one. Let's dark it up to show it to you. And our more transformed function is when 2 sine 3 theta minus pi by 2 plus 4. That's in red. That's in red. So let's darken it now. Now what has happened? What has happened? Now you can see for the blue one, the original one, what is sine 0? If you put theta 0, 3 times 0 will be 0. So sine 0 is 0. So here it is, right? As you can see that. Now what value of theta will be there in this function, the down function, so that this whole thing becomes 0? This whole thing becomes 0. Well, if we'll replace this theta by pi by 2, pi by 2 minus pi by 2 will be 0. 3 times 0 will be 0, and sine 0 will be 0. So when you replace theta by pi by 2, so where is theta pi by 2? You're right, it's here. Here it is. And let me show you how and where it will be. So as you can see, this blue one represents 2 sine theta plus 4. Now theta, if we put 0, the sine of 0 will be 0. So here it is. Here it is. Sine of 0 is 0 plus 4, which is here, 4, as we have shifted 4 units up. So it's 0. And now when we get the red function, the second one, we see that when we'll put theta pi by 2, this whole thing will become 0. And where is theta pi by 2? As you can see here, it's theta, the value of x. You can go down, and you can see it's pi by 2. It's pi by 2. To show you more clearly, let's just erase the plus 4. Let's just erase the plus 4. Now, because we just don't want to confuse you here, and let's talk about it now. The blue one is 2 sine theta. Now talk about it again. If we put theta 0 here, 3 times 0 is 0, and sine theta, sine 0 is 0. So you can see it's 0, right? And in the second function is 2 sine 3 theta minus pi by 2. That means the graph will shift pi by 2 units to the right because of this minus. Now you can see the red one. Look at the red one. In the positive side, where it's intersecting the midline, which is this y equals 0, this x-axis, where it's cutting it for the first time in the same way, going up, positive. Here it is. And what is this? Pi by 2, right? So this whole distance between 0 and pi by 2 is what this red graph has been shifted to the right. And this is the whole distance. You can see from 0 to pi by 2, it's pi by 2 units to the right it has shifted. And that's because we are doing theta minus pi by 2. If we do theta plus pi by 2, what will happen? Well, have a look. If we talk about the original function, well, it's here 0. If we put theta 0, it's 0 here. Now, what you'll do with this theta in the second function so that this total thing becomes 0. So if we have plus pi by 2, if we'll write minus pi by 2 here, right there, so that will be 0. This will be 0. 3 times 0 will be again 0. So as you can see now again, if you talk about the red and it's going down here, where the red is going down here, this blue is going down here, where it is going down here at pi minus pi by 2. So the graph has shifted pi by 2 units to the left because we are doing plus pi by 2. That's all we do. Now let's just add up plus k plus 4. So now you can see this is plus 4. So now our midline is y equals 4. This is the midline across which this graph is oscillating, going up and going down by 2 units up, 2 units down, as the amplitude is 2. And when we do plus 4 to the final graph, the red one, it is also at 4. It's also shifted up at 4 here, and as you can see that we have to shift it to the right by pi by 2 because theta minus pi by 2 is our number. So here it is, pi by 2 is here. You can see pi by 2 is here. If you go down, it's pi by 2 right here. So the graph has shifted pi by 2 units to the right. And this is how we graph all the functions, when we have the value of a, which is amplitude, the value of b, which is the value of b, which is the period, the value of h, which is the phase shift or horizontal shift, and the value of k, which is vertical shift. And this k also tells us, if I want to write it with the help of k, this k also tells us the midline. I forgot to write it before. So the value of k will tell us the midline, which is actually, we just write y equals k. And that is our midline across which the function oscillates. And that's all in this lesson. In the next lesson, we'll do general formula of cosine function, which can also be done in exactly the same way.